Hey everybody, welcome back. Today we're going to be going over web APIs, and then we're going to be building our initial API project and getting it up and running and demonstrating some stuff in Swagger. So let's start off with what is an API? API stands for Application Programming Interface. It's just a set of rules that defines how two pieces of software can communicate with each other. So if you think of a menu at a restaurant, right, it's got a list of menu items that you can make calls to the kitchen with by placing an order, and then the kitchen will fulfill that API request with the expected result. Right, so if you order pancakes, they're going to send you back pancakes. If you order a steak, they're going to send you back a steak. They're not going to send you back a steak when you order pancakes or vice versa. So they're fulfilling the API contract. All right, so what is a RESTful API? REST stands for Representational State Transfer API, and it's a set of rules that defines what your API should look like. And those rules are statelessness. So each request from the client to the server has all of the information needed to process the request. The server doesn't need to remember things about the client in order to fulfill the request. It doesn't have to remember, okay, we're processing a like, but the last request was also processing a like, so we need to do some special rule. It doesn't do any of that stuff. All of the information is sent by the client to the server. The second rule is it's resource-based. Everything is a resource. Our posts will be resources, our likes will be resources, and our users will be resources. Each of these resources should be accessible via a unique URL. So since each of our resources will have an ID, that's what we'll use to retrieve them via the URL. And it uses standard HTTP methods. So what are HTTP methods? Well, they are get, post, put, patch, delete, and option. So for HTTP GET, its purpose is it retrieves data from the server. It's idempotent, which means if you make the same request over and over and over again, you should get the same result back each time. And it should not modify the server state in most cases because you're retrieving data. However, if you're doing something like tracking how often a user has viewed something or something like that, it may modify server state as a side effect. Some examples would be get/API/posts, and that's going to return a list of our posts. Or get/API/post/post ID. Remember, we were talking about IDs earlier and how we're going to treat our posts as resources. This is what I mean. It's going to return a specific post if it exists. Otherwise, it's going to return like a 404 not found status code. So HTTP post, it submits data to the server to create a new resource. It's not idempotent. If you send the same request over and over again, multiple resources may be created. So one example is post/API/posts, and it creates a new post using the data sent to the server. So going back to our menu example, if you are looking at the menu and you want to create a resource or an order, you would send a post request via the wait staff, and they would take that request to the kitchen and they would create your order. And then if you ordered pancakes 3 times, they're going to create 3 separate pancake orders for you. All right, HTTP put. It updates an existing resource on the server or creates it if it does not exist. This is idempotent. So when you make a put request, you typically send an ID, and that's how we know what is getting updated or created. An example is put/API/post/post ID, and it will update the entire post with a given ID. So you need to provide all of the fields that you want to have in your post. If you don't include content, then it's just going to assume that there's no content for that post. Going back to our restaurant example, this is if you realized, oh, hey, I ordered the hamburger with a salad, but actually I would prefer to have fries instead of a salad. So you send a put request via the waitstaff again back to the kitchen to update your entire order. Yeah, so you update your entire order to replace the salad with fries. All right, HTTP patch. This updates a portion of the resource. It's usually idempotent. An example would be a put request to /API/post/post ID. And it updates a portion of the post. So we might be moving the post from draft to published. In our restaurant example, when you update your order, you don't have to tell the waiter everything you want again. You'll just tell them, I would like to have fries instead of the salad, and then they'll go back and patch your order in the kitchen to include fries instead of the salad. All right, HTTP delete. Like the name implies, it deletes a resource from the server. It is idempotent. Uh, since we are deleting a resource, if you request to delete that resource again, nothing's going to happen. So an example is delete /API/post/post ID, and it will delete the post with the given ID. In our restaurant example, that is telling the waiter, never mind, I don't want to eat here anymore, cancel my order. And then they will cancel your order. HTTP options. It gets a list of communication options for the given endpoint. It's idempotent because it doesn't manipulate anything on the server side. It doesn't really return any specific resources. It's just, it's like a metadata call for the endpoint. An example is options API/posts, and that's going to get information about what methods are supported by the API/posts endpoint. So we know we're going to support GET requests, we're going to support POST requests, and that's about it for that endpoint. I never use this one manually. I said I almost never use it manually. I don't think I've used it a single time manually. All right, so that's enough theory. Let's get into actually creating our API project. All right, so here we are in our project. So right now we just have our introduction project that we wrote earlier. We need to create an API project. So let's do that .NET new list again. And we are looking for an ASP.NET Core Web API. So it's in alphabetical order, so it's up here at the top. And here it is, ASP.NET Core Web API. And its short name is just Web API. So we're going to do .NET new Web API -o, remember, because we're outputting this into a directory, microblogger.api, and then we're going to pass in an additional option for this, which is -controllers. The reason for that is there's really two styles of APIs. There are minimal APIs and there are controller-based APIs. I personally prefer to work with the controller-based APIs, but if you guys want to see a version of this course using minimal APIs, let me know in the comments and I will make it happen. All right, so let's run this. All right, so we have our project. However, if you look over in the left-hand side, it's not in our Solution Explorer. Well, let's do ls. So we see we have microblogger.api here. If you remember from our intro to C#, we have to give ownership of the project to the solution. And the way we do that is we do .NET SLN, because we're working with the solution, add microblogger.api. And that's it. Now we have microblogger.api here in our Solution Explorer. So let's change directories into microblogger.api. And we're going to do .NET watch run. And actually, we don't even need the run. We can just do .NET watch. And what this does is it's actually going to watch our file system. And if there are any changes to our app, like we update some code or whatever, it's going to either hot reload the application or it's going to do a full restart of the application depending on what's appropriate. And the alternative is every time we make a code change, we would just do .NET run again. But .NET watch is a little easier to use. All right, so here we are at the Swagger. We see we have one endpoint. It's /weather forecast. So let's open that up, and you can see here it's a GET request. So let's open this up by clicking on it. And you can see here what the example value is going to look like. So let's hit this try it out button. Hit execute. You see it takes in no parameters, so no input. We're just getting a list of weather forecasts. And we'll hit execute. And then we get a response body down here that has all of the data that came back from the server. Now, alternatively, rather than using Swagger, we could hit this endpoint directly by, instead of going to /swagger/index.html, we could go to /weather forecast. And you see here we get a list of weather forecasts back. All right. So how does this work? How does it know that when we go to /weather forecast that we're going to get a list of weather forecasts? So let's take a look at our code. Inside of the controllers folder is where our endpoints live. So our controllers are responsible for taking a request from our client, in this case Swagger, and routing it to the proper endpoint based on the route. So let's open it up and see what it looks like. All right, so you see here where our first line is a using statement, and what that means is we are essentially opening a folder of code, is how you can think of that. And inside of that folder of code, we have things like the controller base, we have the API controller, we have route. That is all given to us by using Microsoft.ASP.NET Core.MVC. Then we have our namespace. Our namespace is that folder of code that we're using up above. And this namespace is microblogger.api because that's the name of our project. .controllers. The convention in C# is that your namespace should line up with where it lives in your file directory. So we have microblogger.api/controllers. So microblogger.api.controllers, right? And this is just a convention, so we could say .weather here. And all that would happen is we would get a little line. You see here it says, do you want to restart your app? I hit A for always. And that way it won't ask again. It'll just restart the app if we make a breaking change. But since we changed the namespace here, everything still works, right? We could go over into Swagger and we could make our request and everything still works the same. All that happens is we get this little warning here. Namespace weather or microblogger.api.controllers.weather does not match folder structure expected microblogger.api.controllers. And it's good to follow the conventions because then when other developers are looking at your code, they'll be able to quickly figure out where things live and what things do. All right. So then we have this API controller attribute. What that gives us is that gives us a lot of built-in data validation. So if we had a model that we were using to create a resource, like for example, a post, then we could set up some rules on that post, like it must have content. And the API controller would automatically reject any posts that don't have content. Then we have this route, and it's just square brackets controller. And this is a special route, because what that does is it takes the name of the controller, which is weather forecast controller, it chops off the controller part, and it's just called weather forecast. And if we look over here in the Swagger, then our GET request is just going to /weather forecast, which matches up with what this route is. All right, then we have some strings that we're using to build a random weather forecast. This isn't super important. We've got an iLogger, which is never being used in this instance, but that is how we would do logging. We'll cover some logging when we get into the services layer. We'll create our own iLogger, and we'll actually use it to write some logs out to the terminal. Then we've got this constructor, and it is using dependency injection, which we'll cover in the services layer video, to inject an iLogger and then assign it to this private logger variable. All right, so if you remember here in the Swagger, this is a HTTP GET request. And the reason for that is we have this HTTP GET attribute here. And it is returning an IEnumerable, which is just a collection of weather forecasts. Now, I don't particularly like this example that Microsoft has because I think if you don't know LINQ, if you don't know what an IEnumerable is, if you don't know what an enumerable is, then I think it's a little difficult to follow. So we're going to just comment this out. And we are going to write our own action method. That's what these are called when they are methods that have routes. They're action methods. So we're going to call this HTTP GET, or we're going to put the HTTP GET attribute here. Then we're going to just do public weather forecast get forecast. All right, so what do we want to do here? Well, we're just going to return a new weather forecast. Remember when we were doing our intro to C#, we had object initialization. That's what we're going to do here. And what do we need? We need a date, which is a date only. So we can say date only dot from datetime datetime.utc now. So a date, there are two ways to represent dates in C#. There is the date time, which, as the name implies, has both a date and a time, right? Like it's Thursday, October 17th at 10:45 a.m. versus a date only, just like the name implies, has just a date, like it's October 17th, but we don't know what time. The weather forecast is expecting a date only, so that's why we did that. Then you can see here it's expecting a summary. It's going to be hot. And then it's expecting the temperature C. We're going to say it's 40 degrees. Okay, so when we get an error like this, when we saved our changes up here, what that means is we need to restart the .NET Watcher. And all you have to do is click here in the terminal and then press Control R. And then we have no more error. All right, so let's try out our new endpoint that we just created. You see it still has the same endpoint, but this time it's going to return a single weather forecast instead of a collection. Let's try it out and hit execute. And yeah, there we go, 2024, 10/17 for the date. The temperature is in Celsius is 40 degrees. Temperature in Fahrenheit is 103 degrees, and the summary is hot. So how did it get this temperature Fahrenheit? We definitely didn't say anything about it in here. So let's go into weatherforecast.cs. So you see here we have properties, right? These are properties because they have the get and set. They're not fields, they're properties. And we have date, we have temperature C, we have summary, and then we have this weird looking syntax for temperature Fahrenheit. This is called an auto-accessor property. And you can tell by the equal sign greater than sign here. And what that means is every time you call this temperature F, it's going to run this math, which is just temperature C divided by 0.5556, cast that to an integer to drop the decimal place, and add 32 degrees. So every time we call temperature F, it's going to read the temperature C value, do that math, and return. So that's how we got this temperature F value and how it's 103 degrees. Great. So that's the controller and the data model covered. So there are a couple more important files here. They are, let's start with program.cs. Now, if you remember in our introduction, program.cs was the one file we had. And this functions very similarly. It is the entry point for our controller, or for our web API rather. And its purpose is to set up all of the dependency injection and all of the services that we're going to be using and configure the environment for our application and then run our application. So let's go through this line by line. We're going to get a web application builder here. Like if we hover over here, it says it's a web application builder. And it is just calling web application.create builder. If we hover over this, it tells us it initializes a new instance of the web application builder class with pre-configured defaults. Great. So now we're going to add services to the container. First, we add our controller services, and that's going to set up all of our API controllers. And then these two lines are for setting up Swagger related stuff. This one's even called add Swagger gen. And then we call builder.build, right? We have a builder, so we want it to build the thing. And it's a web application builder, so we can expect it's building a web application. So if we hover over app, yep, it's a web application. And here's that var type inference again. So builder.build returns a web application, so since we're using var, the compiler knows that. Then if app.environment.is development, which if you look down here in the logs, hosting environment development, so this is true, it's going to do app.useSwagger and app.useSwagger UI. So if we're in an environment other than development, like if we're in production, then that Swagger interface is not going to be accessible. Then if we have an HTTPS port configured in our profile, we will get redirected to the HTTPS. We're going to use authorization, which we're not really using yet. We're going to map the controller, so this is what sets up all of our routes. And then we run our application. Great. So it's pretty straightforward. If it doesn't make sense, don't worry about it too much. We'll be getting more into this file more when we get into the dependency injection and services layer lesson. And we'll be spending a good amount of time in this file at that point. Our next important file is appsettings.json. So what this has is it just has some logging information. I like to have this all default to information. So I get more logs is better in my opinion. So this just has logging information. Later we'll be adding our connection strings for the database to this. We'll do all of our configuration kind of in either this file, or if we click on this drop-down arrow, appsettings.development.json. Now, since we are in development mode, right, hosting environment development, then this appsettings.development.json will override anything in appsettings.json. Like if we had warning here, then our default log level would be warning instead of information. But we want information. There are several different log levels, right? We have critical, which is something really bad happened and we need to shut down the application. We have debug, which is, this is useful information for debugging, but we don't want it printed out all the time. We have error, which is something went wrong, but not bad enough that we need to shut down the entire application. We have information, which is like these applications started, hosting environment is development, so on and so forth. None, which would mean we would get no logs at all, which I don't think you would really want to use that. Logs are super helpful for troubleshooting. Trace, which is you log out absolutely everything that happens in your application, almost line by line. And trace is what you would be using to troubleshoot something that had gone wrong, but you're not sure where it is. You don't usually use trace, especially not in production. And then warning, which is, hey, something looks a little weird, but nothing's actually gone wrong yet. This might be something like, hey, a user tried to delete a post that they don't have ownership of. It might be something like, hey, you have HTTPS redirection configured, but we don't know what port that's configured for, so on and so forth. So we're going to use information for our default log level. All right, so that is a very quick, high-level overview of web APIs and RESTful APIs. In this video, we got our API up and running with our weather forecast endpoint. In our next video, we will be covering modeling our data, and we'll go over an introduction to Entity Framework Core. It's going to be a super exciting video. There's not going to be as much theory as there was in this video. We'll just get right into it and start writing some code. So I will catch you in the next one. Thanks.